All right, good morning, everyone. My name is Greg Wadley with CTC and Associates. I'm the Clear Roads Administrator. We are here today for the final webinar on Clear Roads Project 1805, which is alternative methods for de-icing. That project was conducted by Western Transportation Institute at Montana State University, and the principal investigator is Laura Fay. So I will be handing it over to her in just a moment, but before that, I just want to let you know that we have muted all the lines during this presentation. So if you have any questions or comments, please enter those in the chat box, and I'll put a note in there to remind you of that. And then we'll go ahead and address those questions and comments at the end of the presentation. We are recording this presentation, and it'll be uploaded to the project page on the Clear Roads website within the week. So with that, I'm going to turn it over to Laura. Laura, proceed whenever you're ready.
Great, thanks, Greg. Thank you everyone for calling in and making this happen in this interesting time. So I'm just going to go ahead and jump in. I've got a long presentation, and then we'll take Q&A at the end, like Greg mentioned. So again, this project was titled Alternative Methods for De-icing, and I'm Laura Fay. I served as the PI on the project at Western Transportation Institute, and I wanted to say a thank you to Carolyn, who helped me significantly on this project, but could not make the meeting today. Quick outline, the goal of this is to go over what we did for the project. So I'm gonna provide a quick project objective, go over who deserves thanks, which is everyone on the line basically, review the methods or the tasks associated with this project, and then jump into what we developed, which were the case studies and the recommendations. And at the end, we'll take Q&A. So the real goal of this project was to work to find new information or more information to aid winter maintenance managers in better understanding the performance and impacts of alternative methods for de-icing. And a big part of the initial discussions with this project is, what does alternative methods for de-icing mean? And we landed on it meaning not only non-chloride based de-icing products or alternative de-icing products, but also other methods to mechanically de-ice or aid in that process. So what you'll see here is a combination of alternative products, alternative methods, and quite a few technologies that we identified to really help achieve these goals. So before we get too far, I want to really thank the folks that were involved with this. The Technical Advisory Committee from Clear Roads, everyone on the committee significantly added to this project. So a huge thank you to everyone. I really appreciate it, and I appreciate your timely responses. Really help with the project. I also want to say thank you to all 90+ survey respondents and the folks that provided additional time and interviews to help support this. Thank you to Greg for your leadership and all the support staff at WTI for making this come together. So let's really jump into this. So what did we do? Well, for this project, we started with a literature search. We really were working on building off some documents that were completed just a couple of years ago. So we were looking for newer information in the last couple of years on these alternative methods for de-icing. Once we did a pretty exhaustive international search, we then developed a survey. It was a web-based survey that went out internationally, but we were also able to send the survey out as paper copies at quite a few conferences. So we got kind of a great preview of local roads folks as well as international and national DOT folks, which was great. From those responses, we identified individuals for follow-up interviews. Those were conducted, and then all of that information was used to develop case studies. All of that was then used to develop recommendations, and then here we are now presenting this all as the final report presentation. The meat of this project are the case studies that were developed. The way we landed on these topics is from the literature review and the survey, a long list of case study topics was identified. We then reached out to the technical advisory committee and asked for their input on the top 10 topics. From that list, these were the highest rated or determined the most important to kind of pursue for development into case studies. You can see here that there's actually more than 10 topics here. What we did was, for some topics, we did kind of a lighter overview case study, but for other topics, we did a deeper dive and developed kind of a longer case study that has more case examples in it that are based on direct interviews. And you'll see that in the published document. Excuse me. So jumping into the case studies themselves, the first topic, these are in alphabetical order. They're not in order of importance by any means. They're also not in order of the type of technology, material, or mechanical method. So we're going to be bouncing around a little bit. Again, all these case studies are highlighted in a single chapter in the final report, so you can easily go and reference that direct material. So this first topic we're going to go over is automatic vehicle location, AVL. It's often called AVL GPS technology. They are two separate things that work together, though. Automatic vehicle location uses global positioning systems, or GPS, or signpost beacons to track real-time locations of vehicles. And what you can see from this picture here is you have your snowplow, it's collecting information, it's dropping points on where it is. That information then goes to satellite or another relay system, and that information is then sent to an online tool for you to track your vehicle. Other information that can be tracked includes material use and vehicle operating properties. These aren't necessarily built into the initial AVL package. You may have to have other technology that collects this information, but that information can then be relayed through the same system. As I mentioned, we highlight in the case studies different examples of how this technology is used. And in Idaho, their application of AVL GPS, they were able to realize some significant efficiencies in applications while maintaining the same level of service, which really is kind of the golden egg of, can we improve and find efficiencies while still providing safety and mobility? The folks from Norway provided some great information. They have a unique situation compared to what we see in the United States, where they outsource all of their winter maintenance operations. And all of their contractors are required to have AVL GPS. And what they use that tool as is a performance measurement tool for the contractors. So that's kind of a unique application for us in the US, but not necessarily for folks internationally. Another example of this is the folks out of Ontario in Canada. Similarly, they contract out a significant, if not all, of their winter maintenance operations. And they also use the technology as a performance reporting tool. In Ontario, they also indicated that they have a plow tracking website, and they post this information on their 511 website as well. So one question that commonly comes up is, should we provide this information to the public? And what we wanted to show is that quite a few state DOTs and international agencies are providing AVL GPS plow locations. And so if that's something you're thinking about, you can then kind of reach out to these agencies and talk about the pros and cons of whether that's appropriate for your agency. Another example of AVL GPS implementation is in Pennsylvania. They have just over 2,000 vehicles outfitted, and they track routes, material use, and they use it for optimizing dispatch of vehicles. They also post this information to their website. They have a Where is My Plow website, and it also posts to the 511 system. Moving forward. So the next case study topic was blending liquid de-icing products. And oftentimes nowadays when we talk about blending products, we happen to be talking about chloride-based brines. And that happens to be because they are the most commonly used liquid products out there. But this does not mean that you cannot blend other types of products. We just focus on chlorides because that is what we found in the literature and what folks were talking about in their survey responses. Liquids are often blended because you're looking for some sort of enhancement in performance. Maybe it allows your product to work at colder temperature. Maybe it provides corrosion protection. Maybe it's enhancing melting capacity or longevity on the road, or maybe you're trying to hit all those points. As I mentioned, chloride-based products are often blended. These can be purchased blended already from the vendor. These are often proprietary protected products. So you may have a basic understanding of what the base constituent is. So it's a sodium chloride based brine with some additives. And these can be purchased and applied directly. You can also blend your own products in-house. This gives you more flexibility with your blending ratios and different products that are added, but that also puts on your agency the quality control of the product, and you need to make sure you're blending and you're getting the performance you want instead of all of that being on the shoulders of the vendor. Oftentimes, if you do have liquid capabilities and you can blend in-house, it is often cheaper than buying it directly from the vendor. But again, then you have to do all the testing on your own. So products that are commonly blended, usually you're starting with a sodium chloride or a magnesium chloride based brine, and then you might add an agricultural byproduct, you might add a corrosion inhibitor, you might add a cold temperature enhancement, and these will all help you reach whatever your goal point is. Are you looking for corrosion protection? Are you looking for the product to work at colder temperatures? Are you looking for something that's going to stay on the road longer? So you really want to target your blend based on what your goal of the product is. So what are some examples? Minnesota DOT provided an example. They purchase a blended product. It's a salt brine that has a calcium chloride additive for colder temperatures, as well as an organic additive for corrosion protection and I guess stickiness or enhanced kind of performance on the road. What they found in using it is that they are paying $1.30 more per mile for this product, but compared to the rock salt application, they're using significantly less product overall. So they see this as a good functional product that's helping them hit their mark, and they're using less of it over time, even though they might be paying a little more for the product itself. So moving on to the next topic, we're talking about de-icer application rates and timing. So what you'll see as we go through these case studies is some of them are technologies that you might need to purchase. Some of them are practices that you could implement on your own without any real investment. And this happens to be one of them. So what's critical to think about is your snow and ice control material application rates and timing can be tailored to meet the needs of your agency, specifically in your different climate and weather patterns. An example of this might be a shift to anti-icing or use of liquids applied ahead of a storm if you want to reduce material use overall. An example of this is Utah DOT provided us their summary table that they provide their snowplow drivers. And they provide guidance on the storm type, the temperature, and the application rate. So in order for a plow driver to successfully implement this, they need to be able to see what the conditions are, and they also need to be able to know what the pavement temperature is fairly accurately. And from that, they also need to have control over how much material is coming out of their truck. So you can provide great guidance, and then you can provide your drivers with tools, and you can work together to modify your application rate and your timing based on conditions that you see. And from this, you can find quite a bit of savings in application and time out. If you have a lighter, warmer storm, there's no need to put out the heavy 250 pounds per lane mile if it's not needed. All right, moving forward. The next topic is direct liquid application routes, or DLA routes. And this has been talked about quite a bit in the last couple of years. Essentially, DLA is applying liquid-only de-icers on the road surface. So in a way, it's anti-icing, but it could be before the storm, or it could be during the storm. And one really important note is that just because you are choosing to use direct liquid application does not mean that it's appropriate all the time. Just like any other tool, it has an appropriate use and appropriate time. And we'll go over that a little bit. So when you're talking about using DLA, you have to consider three main factors. What's your pavement temperature? What's your storm like? And what's your moisture content of your snow? And these are critical components that'll determine the success of a DLA program. So from an overview document that was put out fairly recently, which we do reference and you can go directly to from our report, it's most effective when temperatures are at or above 25 degrees Fahrenheit. For the folks in Canada and Norway, if you're on the line, I apologize. I don't provide Celsius in all of the slides, but we do in the report. So again, temperatures at or above 25 degrees Fahrenheit and a snowfall rate of around 1 inch per hour. So fairly warm and not a super high snowfall rate. But when we look at how people are actually applying this, what we find is that, for example, in Ohio, they have targeted temperatures actually a little colder, so 20 to 25 degrees or warmer, but their snowfall rate is less than half an inch per hour. So much lower snowfall rate is how they're applying this. But from their routes where they're using DLA, they're seeing a 30% cost savings from the switch to liquids from solids, which is a significant amount of savings. We also highlight some work done in Wisconsin where they were able to see a 52% reduction in salt use on DLA routes. And what they found was that on these routes, they were able to clear them faster. But what they noted was that you're applying a brine, and the brine only lasts about 2 hours, where with the solid material, they were getting up to about 6 hours out of it. So what they needed to do with modifying their practice was to increase their route cycle time. Moving forward, another technology that we talked about is using pre-wet or slurry technology. And pre-wetting is that tool where you apply a liquid to a solid de-icer. So maybe you have a rock salt that you're then adding a mag chloride to, or maybe you have a rock salt that you're adding a beet juice to. It's your choice. And the concept of slurry technology is you're pre-wetting, but you're pre-wetting at a much higher rate. So you're adding way more liquid to that solid material, and it's going to be more oatmeal-y in consistency. I think a lot of folks are talking about pre-wetting, so we're well versed, but the benefits of pre-wetting and slurry can be huge. They can reduce bounce and scatter of material as it's applied, so that keeps the material on the road where you want it and less material in the environment. When the product goes out wet, it sticks, and that wetness is that brine that you need to help accelerate and start that work, that melting process. And overall, using pre-wetting and slurry can reduce the amount of product that's used. So there's been quite a bit of talk, and we did get some great feedback from Quebec and Canada. They're using a rock salt pre-wet with beet juice, and they've found a 30% reduction in salt use while maintaining level of service. But for them, the temperature range was very important, and they target around 25 degrees Fahrenheit or -4 Celsius. Maine DOT, they provided some feedback that they found that the larger grain size works for the colder temperatures, but they can get away with smaller rock salt particle size at warmer temperatures. And some work by Minnesota and some feedback from them included that they found that they really needed to drop their snowplow speeds to about 25 miles per hour to get good placement of this material and keep it on the road where they wanted it. So one of the case study sections that we kind of took a deeper dive into and looked at were mechanical snow removal methods. The technical advisory panel was really interested in getting as much information on this topic, so we highlight quite a few in the report that I'll go over here. The first is Icebreaker technology. Essentially, icebreakers or penetration drums use metal spikes or blades to break up packed snow and ice that's already bonded to the pavement. And they break it up into small pieces that are then, after the fact, plowed off the road. And what you can see in the picture on the right is the gentleman holding an ice chunk that's been broken off. And the picture on the left is up in Alaska, and you can actually see the drum with the metal spikes on the end. So, you know, enough people have tested and used this technology that there's some really good lessons learned. One of the biggest concerns that folks mention is damage to pavement, but everyone that we spoke to said that while that's a concern, they were able to manage it by being very cognizant and aware of the down pressure that they're applying. Obviously, the thicker the ice pack, the more downward pressure you can get away with, but you just have to be careful to not apply too much and damage the pavement. And in the report, we actually provide their guidance on the PSI pressure that they use to avoid damaging the pavement. They also note that it's really hard to turn with this equipment, so try and keep that to a minimum. So nice straight stretches it's going to work better on, and that your driving speed needs to be fairly low, 15 to 17 miles per hour. So you're just working on really going slow and breaking up that ice. And obviously, any in-place infrastructure like bridge joints or railroad crossings, you need to be very careful of, and maybe just even lift it as you go across those. So examples that we found, I'm sure there are more out there. Alaska, Minnesota, and Utah have all tested similar and different technologies for icebreakers. The cost range is from the different manufacturers. There are a couple out there. We do highlight all of them that we're aware of in the report. And the range is $30,000 to $45,000 for the equipment or the attachment to your existing tractors. The feedback from everyone was that they work really well at breaking up packed ice. And another side piece of this was as they penetrate the packed ice and snow, they create fractures in it. And so it actually allows the de-icer to get down to the pavement and really helps with plowing the material and breaking it up over time. But they were able to realize a reduction in salt use because they're not trying to burn through that pack anymore. They're creating a nice textured surface usually, so you get a higher friction value even if it is a packed snow or ice surface still. Another mechanical removal technology that we talk about are rubber and squeegee blades. It's funny, when we went to conferences and we asked folks about these, they either love them or they hate them. The feedback that we found from the literature was different. Essentially, I think you hear about the positive examples in the literature. But what you can see here are two different ways to mount these. You have a single rubber blade, whereas on the right you have a plow blade with a rubber blade on the back. And there's any number of ways you could potentially mount one of these. But the rubber blades and squeegee blades are really designed for removing slush or light snow and essentially just kind of scraping it off very gently. There are huge advantages of these. If you have a really wet or really light snowpack, they can remove it very effectively. They do not damage roadway markings. So if you have a lot of above elevation markings, or if you have some kind of historic pavement types like cobblestones or brickwork, these work very well on that. And again, they can be used in combination with other blades. So they can be used as kind of the final clear to remove that last bit of material. There are some cons. You have to be very aware of your downward pressure. If you apply too much pressure, you'll just wear it out very quickly. And then also, a lot of folks talked about using these on concrete, and they work great. If you do use them on an asphalt that has a high friction overlay, like a chip seal or something, they will wear quicker. So just be aware of that. Here's an example of 2 agencies that have tried these. Iowa tested a 3-blade configuration. So they have their main plow blade, followed by a scarifier, and then followed by that squeegee blade just to clean it out. And they did some testing with it with sand, and they found that with that squeegee blade on, they were able to remove 20 to 25% more of the sand in that test. So a significant amount of material was removed. In Norway, they did some field trials as well, and they were testing the squeegee blade and driving speed. And they tested it, and what they found was that the slower you drive, the more material you remove. So it's kind of a common theme with this document. At 25 miles per hour, they received about 90% slush removal from their test section. So again, if you can target 25 miles per hour with your driving, you're going to see huge benefits in multiple different facets of your program. Another example is in South Dakota, they tested a multi-blade prototype. You can see the picture here. Each squeegee kit, so the materials and the maintenance or the labor, cost just under $3,000 per unit. And in their testing, they were able to go from 150 pounds per lane mile down to 75 pounds per lane mile. And so they were seeing a cost savings of $150 per route pass. So just 18 passes allowed them to pay off the squeegee blade investment. So those are some real numbers, and that's a great example. And you can see here how they configured the setup for that. Another example from Norway is they're testing multi-segmented rubber blades. And they really like these. They feel that it does a great job at removing slush, especially from deep ruts. Out here in Montana, we can get really deep ruts. The slush just kind of build up in those.
Hi, Laura. This is Greg. You cut out there for about 10 seconds. So if you could go back and recover that again, please.
Yes. Sorry about that, guys. So the last example of the rubber squeegee blades is from Norway, where they're using a multi-segmented rubber blade. And what they've found is these blades are great for removing slush from deep ruts in the roadway. And a quick, easy segment is the last mechanical snow removal method that we highlighted, were these multi-segmented plow blades or articulated plow blades. The benefit is that they really can conform to changes in the road surface, whether that's ruts, as I previously mentioned, or potentially a manhole or some sort of built-in infrastructure that will get in your way. They do allow for good cleaning of the road surface while not damaging in-place obstacles. Oh, I forgot, there's one more. So the last, I promise this time, snow removal technology we talked about were brooms and sweepers. And this was kind of a new exciting thing to look into for us. These are commonly used at airports and on sidewalks, and are now more commonly being considered for use on roadways. Some lessons learned that we were able to pull from folks is that, the purpose of these brooms is they are not plow blades. They are not designed to scrape material off the road. They have a very specific use, and we'll go over that shortly. But when you do use them in the right conditions, they can significantly reduce the amount of material you need and the amount of time that you put out there. And they also are good at removing slush from the roadway. So in Wisconsin, the city of River Falls, they're able to use sweepers up to 6 inches of snow, which is a lot, but what's critical here is that it's low density snow. And the test that we use at our house with my boys is, can you make a snowball from it? If you can make a snowball and hit your brother, then that's a very dense, high water snowpack. If it's light and you cannot make a snowball from it, then it's probably a low water density snowfall. I'm sure you guys have much more fancy techniques for doing that than we do at our house. Another example is in Minnesota. They only use their brooms up to 3 inches of snow, and I'm guessing it's a higher density snow. And at that point, as soon as they get close to 4 inches, they're going to pull the plow out and start plowing instead of using the brooms. One really interesting thing that came out of this was we were able to interview the university in Bozeman. They've had a broom program for over a decade, and they've learned a lot. And universities are unique because you have roads and walking paths that all kind of intersect. There's lots of walking and biking, even in winter, which I think they also see a lot of in Norway and other European countries. And so they were able to provide kind of good long-term feedback. And what we found was that they need to replace their broom bristles about every 200 miles. So what they're able to do is they're able to run their about 15 passes on each route, and then they bring that broom in and they replace the bristles. And they're able to do that in the downtime. They just know that that is the routine maintenance. They also commented that training on this is very easy. It takes about 1 day for one person to figure it out. Maintenance and repair very straightforward and generally very easy to get the parts. The only caution that they provided for us was that if you plow and then use the broom, you can create a really nice polished, low friction, very dangerous driving or walking surface. So be very careful of that. And then the final example of this are the folks in Norway. They have this prototype that they were testing. It's a very expensive piece of equipment compared to the setup. I'm going to go back for a sec so you can see here maybe a smaller unit that mounts on an existing piece of equipment. So this is a tow behind unit. You can see it's being pulled by a brine truck. But what they've found is that it reduces the need for de-icers and therefore reduces the environmental impacts of their program. They provided actually a very extensive list for us of pros and cons, and they see all the same pros that you do with the smaller units. The cons with this specific piece of equipment that they noted were that it's a very big piece of equipment, it's tough to maneuver, it's expensive, and this specific type of equipment requires significant amount of training, whereas the smaller units I think are a little easier to train on and maneuver with. Another case study that we highlight are methods to reduce chloride use. And so there are many reasons why you may want to reduce chloride use. Maybe that's just increasing awareness of environmental impacts. Maybe from the top down, you've been told that you need to reduce costs overall, and the bulk of your cost is purchase of salt. Maybe you're being regulated on, or you know that regulations are coming for reducing chlorides in ground and surface water. There's all different reasons, and there's different ways to go about reducing. Maybe you're going to look at alternative de-icing materials, or maybe you want to look at changing some methods so that you can reduce your application rate. Just a few examples that we highlight here, there's definitely more provided in the report, but Michigan, they identified 44% of almost 400 lakes that are at risk of long-term salinization. So that means that chloride levels are rising, and they're rising steadily over time to a point where once you get chloride levels to a certain point, you're going to see impacts to buried infrastructure like pipes. You're going to see impacts to humans through taste. And as you all know, it's very hard to remove chlorides. So it's better to just not put as many into the system. What they were able to do in Michigan is implement some salt management initiatives. So they were able to look at their spreaders and what they're putting out. They were able to reduce their driving speeds, and they're starting to pre-wet and use MDSS to really support this initiative. And in Minnesota, actually with the help of Greg, they set up a salt sustainability program. It's a great website with many tools. There's training, there's identified best practices, the concept of calibration and how to use that, using existing tools like MDSS, material selection, and handling and storage to support your program. One case example that we highlight is with Illinois DOT at the local county level and a conservation foundation. I really wanted to highlight this because I think a lot of folks are afraid of being told that you're putting material out there and it's causing problems. But this is an example of an agency that was told that, and they were able to work with folks locally and get support from them to help improve their program. What ended up happening is that a water treatment facility was having issues, and they identified that salts were causing the problem, and they were actually able to trace it back to application of de-icing salts as a significant portion of the issue. They approached the DOT and the Conservation Foundation that did some of the testing, and they agreed to start working together. Instead of being kind of enemies, they became friends, and they set up a series of technical workshops, and this created an opportunity for them to work together on the testing side and finding out what concentrations were and actually modifying practices to achieve better results. What they needed to focus on, because they didn't have extra money to spend, were practical, low or no cost changes for the DOT. So what they looked at were anti-icing and pre-wetting. They looked at calibration. They looked at using pavement temperature data to make their decisions on what they were going to do, and reducing their plow speeds. And what was amazing is they were actually able to see in the water treatment facility water a 40% reduction in chloride and chloride use over the seasons from these practices. So again, it doesn't have to be a huge investment to equal a huge benefit in the end. And in hindsight, I think from both ends, the conservation group as well as the DOT, they wish they had collected more data just to further reinforce all the effort and all the benefits that they were seeing. The next topic is route and fleet optimization. And this is a tool that can be used. The goal of this technology is to maximize efficiency of routes for snowplows or your fleet in terms of locating them and minimizing costs while maintaining level of service. So what is it? Well, it's generally a software package or a private company that you hire to do this for you. You can do it in-house. There's quite a bit of reported information out there on this, and across the board, people are seeing a 5 to 10% reduction in route lengths. And so that equals savings in terms of time, material, and equipment wear. So route and fleet optimization can provide significant benefits. The biggest caution that everyone told us and that you read in the literature is you need to involve your plow drivers fairly early on and get their input. If you hire someone from the outside to run this optimization software, you might hand it off to your drivers, and they might say, this is a 2-lane highway with a barrier in the middle. I can't cross here. I can't end my route here. Or they may say, this is not a turnaround point for me. This is a closed off, defunct parking lot that doesn't exist anymore. So getting their input is critical early on. They can really help with designing and optimizing these routes. Some examples of agencies that have used this technology. In Kentucky, what they were able to find was that their route optimization allowed them to eliminate 9 vehicles. And that led to a cost savings of about $250,000 annually, just from not needing those vehicles anymore. In Ohio, they were able to extend their routes actually beyond county lines, and that actually optimized their routes better. It decreased treatment times, and they were able to overall eliminate 29 vehicles while achieving the same level of service. So real money, real benefits. All right, the next case study topic that we covered was alternative de-icers. So what else is out there besides salt? I mentioned blending of material already and optimizing application rates, but what are our other options? Well, sand has been used for a long time, and it's been used longer than chlorides, longer than salt. But there are other products out there commonly used by airports. And then there's some other products like agricultural products like beet juices that are out there as well. But one thing that's really important to note is that there is no one best de-icer out there. Every de-icer is going to cost something, and every de-icer is going to have some level of impact. Even sand, not being a de-icer, is going to have its costs and it's going to have its impacts. So you need to be aware of those so that you know what those are. And I apologize. Please note that ODOT is Oregon DOT, not Ohio DOT. Sorry about that, Patty. There are too many similar acronyms. So some examples that we wanted to cover were the no salt option. What are they out there? So abrasives. Abrasives are a reasonable option. They do not provide any de-icing. The goal of abrasives is to improve friction. The upfront cost of abrasives is often very low, but what ends up happening, as folks know, is you end up blending a certain percentage, usually of salt, with your sand, so it's workable. So it's not truly a chloride-free product usually. They can work at any temperature, which is wonderful, but they need to be cleaned up. And when you fold in the cost of your cleaning program, generally sand becomes as expensive, or if not a little more, than chlorides. So if you're doing this for cost reasons, you need to maybe rethink how you're going to make this more cost effective. And one way to do that is if you have approval already, or you can seek approval to reuse your cleaned up abrasives. I know not every state can do that, but if you're interested, some states can. I believe Oregon is one of them. Go to your environmental quality agency and talk with them about a recycling sand program or abrasives program. Usually what it involves is screening trash and other material out of it, and then also some basic testing to make sure that your heavy metal concentrations are not really getting too elevated in that material. But again, sand is not perfect. You have to clean it up, and it does have its impacts, and those can be air quality impacts. Those can impact roadside plants as well as waterways with decreased water quality. What are the other options? Well, there was a whole list of acetate. There's common ones are potassium acetate, which works well in at cold temps. There's calcium magnesium acetate, or CMA, which works about equivalent to salt, similar temperature range. There are formates, there are succinates, there are glycols. What we wanted to do was really highlight who is using what and how, and I have to be honest, it was really hard to find examples. examples of people who are using it. We reached out to a couple states, and we've highlighted examples that we found and were able to verify. So I think the next step of really seeing who is using alternative de-icers is to have folks step forward and talk more about what they're using and how they're using it. In Michigan, they use CMA on some key bridge infrastructure. They've been using it since the late 80s. And the reason they chose that was corrosion protection. And what they find is that they only use about 100 tons per year. The cost is high, but that cost is justified because of the protection to that infrastructure. And they've had good success with it. We also spoke with folks in Alabama, and they're using, initially they started using CMA on bridges and concrete for corrosion protection. And up north in the northern part of the state, they're starting to use more potassium acetate. And what they find is that it's the same cost as CMA, but they can get away with about half the application rate, and it works at colder temps. So they're kind of having a shift within their state to other acetate-based products. All right, so the last section of the case study chapter is on using data and reporting to make informed decisions. And this really is kind of the future of winter maintenance, is we have all this new technology in the plows and on the roadsides, and it's how do we use that to better inform your program. And that information could be captured with technology. It could be very fancy, like the AVL GPS units, or it could be as simple as someone manually at the DOT shed recording how much material they loaded in their truck, and then when they come back, how much material is left in their truck. So it really depends on what capability you have and your ability to collect that information, but then also apply that information. Some examples of how you can do this, kind of on the high data end, is using a winter severity index or a storm severity index. There is an existing project right now with ClearRoads that provides you kind of with a step-by-step how-to guide if you're interested in applying this technology. There are a lot of great resources on examples of developed weather severity indices. But the premise is that you use historical RWIS or weather data to determine the severity of winters. So is one winter season more severe than the last, or is one storm more severe than the previous? So that you can compare your cost of operations and your effort to the severity overall. An example of this that's commonly talked about is in Idaho. They have an RWIS data-based weather severity index. They look at wind speed, they look at snow or ice layer thickness, they look at pavement temperature, the duration of the storm event, as well as friction. This was started by a single person. They developed it in-house, and they calibrated it for their state in-house, and then it was implemented statewide. They got to a point where they were able to hand it off to their weather data provider, Vicela, who now runs that calculation for them. That freed up time for them to improve it over time and then give Vicela the kind of more robust second version that they have now. What's really important to note from this experience and a lot of other states is a weather severity index it's a model of data. So it's based on numbers, and it will improve over time with more data, and more and different parameters can have different impacts on it. So it's an iterative process. It's a thing that will change over time. And it's important to know that it's not something that you do once and that will be the answer forever. Another example of using data to make informed decisions is the MDSS Pool Fund program. It's a computer-based customizable winter maintenance tool It's a great example of agencies working together to come up with a new technology that's now a web-based tool. It provides route-specific weather forecast information, treatment recommendations, after-action training, as well as now there's a new component where there is weather severity analysis built in, where you can select the type of weather severity calculation that maybe applies best to your area. So there are all sorts of different tools within this. If you are a part of the pool fund or thinking to become a part of the pool fund, it is a tool that's out there. Interestingly, the last analysis kind of the functionality of MDSS was a while ago, but at that time in 2008, 2009, folks were seeing significant savings in materials. In Indiana, they saw about $9 million worth of material savings and a reduction or a savings of $900,000 in overtime expenses. So that's a lot of real money. And while MDSS is expensive, if you can see that type of savings, maybe that is a good investment for your agency. Some feedback we got from other states, including Minnesota, were that folks that are a part of the pool fund have highly variable levels of implementation of it across the state. Almost like one district is really into it and they have a lot of trust within it, and other districts don't. So that's definitely one area of improvement that could be seen overall with implementation of this technology. And the last component of the case studies is using dashboards. And dashboards are essentially a visualization tool. It's a way of making pretty looking graphs that help us all understand what the data means. And this is a great example of salt use over time. And it's very clear that their average, the black line in the graph, is their average salt use. Then they have some high years and they have some low years. And they can rate themselves based on what they're doing over time. These report cards or these dashboards can be used to show agency effort within the agency. So you could provide this, say, to your supervisors, to your politicians, but they also provide a level of accountability to the public because they can visualize what you're doing better than you explaining it and say, wow, we put down 150 pounds per lane mile. That's really good. That doesn't mean a lot to the average person. Some examples of implementation include kind of the classic Iowa DOT years ago put together the salt use dashboard. And this has kind of laid the groundwork for other people to see how effective these visualization tools can be. At this point in time, they have an internal public dashboard that's used, and they can see down to actually the shed and even for specific drivers, who's doing what, how much salt they're using. And then they have a public facing one that's kind of a more general picture of what's the agency doing overall. And they're reporting material use and performance, and it's a great tool for them. Another example that we identified is in Wisconsin, they have their MAPS dashboard, and they're looking at mobility, accountability, preservation, safety, and service. And it's an annual scorecard that they publish. The maintenance managers use it to track performance, and they're really hoping to use this tool to help reduce salt usage over time by tracking what they're doing. So the last part of this project was really developing recommendations. And I'm not going to go too deep into these here, but I wanted to let you know that for every case study topic that was developed, there are recommendations for implementation provided. Something that we really wanted to focus on that was great feedback from the Clear Roads Technical Advisory Panel was this concept of doing a lot with a little. Making very large improvements to your program can be done without significant investment. And so we highlight equipment calibration. We highlight changes in vehicle speed. So could you reduce your plow speed across the board to 25 miles per hour, or test it at one shop or with one driver and see how that impacts your program? Looking at variable application rates based on conditions. or using the data that you already have in a more effective way. And ideally, these low-hanging fruit you could identify and test and implement across the board, or just even at shop by shop, just to gain support for them. But once you've kind of exhausted this list of low-hanging fruit, then you really need to bring out the big guns. You need to look at what sort of financial investments could we make to really improve our program, or what sort of major program changes from the top down and bottom up need to happen at this point in time. And so we go over examples of that as well. And one of those is looking at benefits and costs for investment. And what I wanted to show everyone is that a cost-benefit analysis can be really complicated, but it can also be really simple. And so here's just an example. Let's say your agency wants to start pre-wetting. You have some liquid anti-icing capabilities already. So you just need to do a minor investment of, say, $5,000 per year so you can start pre-wetting your material. From your program after the first year, you see $1,000 savings in material. Okay, that's great. So you divide your cost of equipment by your savings, and you see that in just 5 years, your investment has paid off. That's a good return time. And knowing that your equipment is hopefully going to last longer than 5 years, you can say that that has a positive benefit cost. And this can be done with any equipment or change in practice. You just need to track your costs internally and how that's going to impact you. Another topic that we discussed with the ClearRoads technical panel was the concept of going from good to great. Everyone has a good program, and within every program, there are great parts of it. But that difference of taking everything from good to great is significant. It's like having an A in a class and wanting to go to an A+. It's a huge amount of effort, but it can really pay off. And so what we wanted to encourage and make people aware of is this difference of going from good to great. So that requires going the extra mile, getting top-down and bottom-up support and coordination, having funding to do what you need to do, training effectively, evaluating and being held accountable of what you're doing, and all while striving to improve. So it's a huge ask, but there's a huge reward at the end. So we wanted to bring that to the table as well. We also wanted to outline some general steps to help support your implementation of any of these ideas. So what we'd like, if you're interested in taking a new concept or technology, is start with just listening, learning, watching, call, talk to someone, go to a conference, you see a presentation that really interests you, talk to that person afterwards. How did you do it? What worked? What didn't? What's it going to cost me? Really reach out to folks to make sure you fully understand. The next step is like, okay, how can I apply this within my agency? Set your goals for whatever this change or technology is and how it can modify your performance metrics or improve them. Then set up internal meetings, talk about how can we do this, who would be involved, who wants to pilot this. Really look at what are your low-hanging fruit, what's going to be the least cost for the most bang, or are you going straight to the big investments, or have you already done all the low-hanging fruit and you're ready for those larger investments? Develop an implementation plan, implement it, collect the data on it, and review it. Critically look at your practice. Is it working? Is it not? What worked? What didn't? And then focus on where can we improve? Where can we see more success? Where were the benefits? So for every little thing that you do to change in your agency, you can take all these steps to really find success in each individual one. And along those lines, you're not alone in doing this. There are many opportunities for training to support implementation. Maybe you have an in-house training program. Maybe you use your seasoned veterans and your in-house knowledge to teach the new hires. Use the vendors. If you are paying them for their technology, they should be training you on how to use that technology. There are also professional trainers out there that used to work at local agencies and DOTs that have retired, and they are not ready to quit yet. They are still out there and they're actively training, and you can reach out to them as well. I know right now we can't attend conferences or peer exchanges, but they're invaluable in what you can get from them, and just meeting someone, hearing their experience, knowing that you can call or email them, it's invaluable. Once things change, it'd be great to go back to that format and get more folks going to these peer exchanges. There are also existing training programs in place through AASHTO, APWA, SITE, Clear Roads, Iowa DOT, your local LTAP, that's your local technical assistance program in your state, SICOP. All of these resources for training are provided in the report with a link, so you can go straight to their website and find the information that you're looking for. There are also webinars like this one through Clear Roads, different agencies like that, states, federal highways, TRB, there are many options, as well as the SICOP podcasts that are out there right now, and you can get those if you have a smart device. You can listen to those that way, and I listen to them when I drive in my car. You're also always willing and able to develop your own training materials for your needs. We also provide an implementation checklist just to help you. Did you involve the right people? What are your goals? What are the issues and your opportunities? Who and what can we leverage in this experience? What are our resources? There's just a ton of support there for you as you work through each of these potential options for implementation. So to stay on time, I'm going to end it there, but note that there's significantly more detail in the report on every topic that was shared today. So again, go to the website and you can look up more information. So I'll take questions at this point in time.
All right, thanks, Laura. So the first question we have is from Patty Caswell at Oregon DOT, and her question is, why apply salt to slush that can be plowed off? Or is the salt saved because there is less slush on the roadway that will refreeze and require less salt or require salt application?
I think this has to do with when we were talking about the rubber blades. Patty, correct me if I'm wrong, but yeah, the whole premise of the salt savings is that you don't need to apply salt to slush, and that the rubber blade will fully clear it from the road. So there is your salt saving there. I hope that answers your question.
Okay. Patty also, she had a comment, said Oregon DOT used CMA early on. Apparently, we found it didn't work real well below 32 degrees. Cliff Spoonmore mentioned that, from Wyoming DOT mentioned that another training resource is Professional Snow Fighters Association, which is a relatively new one led by Wilf Nixon. And Patty confirmed, yes, she was talking about the rubber blades.
Okay, great.
Okay. Cliff also from Wyoming also asked, does the report give examples of how to measure your success if you try one of these methods?
Not directly. We definitely point you to resources in terms of reporting that have worked well for others. So like the SALT dashboard used in Iowa, or the MAPS tool in Wisconsin. So we don't provide any direct examples, but that would be a great next step, is to really kind of provide a how-to guide of that. But there are so many great resources out there, and I know people are willing to share their programs. So if you don't want to have to develop one in-house, I know that you can reach out to some of the states, and they'll show you how they report their data to help show performance and changes over time.
Okay, I think that's the last of the questions or comments I have. Does anybody else have any? Oh, here we go. So Todd Law from Vermont mentioned that VTrans just started using the Salt Saver two-stage blades that are built by Viking. Not much for information as they are new.
Okay.
You know what, I think what I will do here is go back and I'm going to unmute everyone just for one final opportunity to ask any questions or provide any comments that you might have. So.
June and May or July.
Okay.
So
yeah, this is the growing season.
All right, that wasn't going to work because people are talking in the background. Okay. Last, final opportunity for questions or comments. All right, hearing none or seeing none in the chat box. I want to thank Laura again for her work on this. We are, as I said, I recorded this. I will be posting this on the ClearRoads website within the week, and then we'll also be finishing up the final report here very soon and be posting that as well. So, Laura, again, thank you for your time today, and to everybody, have a good week.